The code we currently have for controlling the smart RGB LEDs, it works, but it's not ideal for one big reason, and that is because it uses the delay commands to keep the LEDs in a certain state for a certain period of time, in this case 500 milliseconds or half a second. The problem with this command is that it's blocking, which means that it blocks the microcontroller from listening to or commanding anything that's attached to it while this command is happening. So basically your microcontroller is doing nothing for a half second, then it goes to the next command until it reaches this one and again does nothing for a half a second. That's going to be a problem down the road if you want to attach a button or listen to a button or make a piezo play music. You need to be able to control those devices all the time. So to get rid of this command, we're going to have to learn a few other Arduino commands. So I'm going to close my code window real quick and add an Arduino Uno. The reason I'm adding an Arduino Uno is because an Uno actually has the ability to communicate with the serial monitor. So we can program it to print things to the serial monitor so we can sort of see what it's thinking. When I click back on code, you're going to see that it's in blocks mode because we're trying to program the Arduino Uno. There's actually two different things I can now program. I can switch between the ATtiny and the Arduino Uno. To get out of blocks mode, just click on text and you'll get the same warning we got in the past. And then delete the code that's inside the loop and the setup. We're going to replace that line with a line that says serial.begin, and what this does is it lets us start communicating with the serial monitor, which you can see down here and access by pressing this little arrow. The next thing we're going to do is do serial.println. The ln means a new line. And we're going to print the millis for the Arduino. Millis is the number of milliseconds that have passed since the Arduino started up. So when I click Start Simulation, you'll see these numbers growing quickly. It's just keeping track of how many milliseconds have passed. It's actually going kind of slow because it's operating in a virtual environment in this browser that doesn't run at real time. But you get the idea. It's just keeping track of how much time has passed. Now, I want to use the millis to alternate my LEDs. To do that, I can take advantage of a different function called the modulus. I'm going to go ahead and clear my serial monitor, and I'm just going to print a few different numbers here and see if you can figure out what the modulus does. If I type in 4, and then the percent symbol in this case is the modulo operator, and then I'll say 4 modulo 3. And I'll run it. And it prints a 1. If I do 5 modulo 3, it prints a 2. What's happening here? The modulo operator basically is the remainder whenever you do division. So 5 divided by 3 has a remainder of 2. 4 divided by 3 has a remainder of 1. I can use the modulo operator to make something toggle between two values if I do a modulo of 2. I'm going to put the millis command back in here, and we're going to see it alternate between two values. So you can see it alternating between zeros and ones. That's exactly what I want. I want to be able to alternate between zeros and ones, but the problem I'm going to have is it alternates too quickly. These NeoPixels are going to flash between green and red really, really fast, and I want them to flash slower. I would like them to stay red for a half a second and then stay green for a half a second. So to make that happen, I need to modify the time so that it sort of passes slower. To make that happen, I am going to get rid of the modulo operator for just a minute and do division by 500. And I'm going to start the simulation. And you're going to notice something. I see a bunch of zeros to begin with, but after time, I start seeing ones. And then after more time, twos, and then threes. So what's happening here? It's a little bit tricky to see when we just look at millis divided by 500, but if I do another serial print command, and then space them out so we can see these two numbers separated. I'm going to put a tab space between them. Oh, I better put the print command here and then start it again. I can see these numbers, the millis, increasing, and then when it gets past 500 it becomes a 1. Once it gets past 1,000 it's going to become a 2. You may be wondering why I'm not seeing decimals over here like 1.1, 1.2, 1.3 as it gets bigger. It's because this is integer division. So a number like 2,348 divided by 500 doesn't turn into 4 point some decimal. It just turns into 4. It truncates or chops off the end of the number. And that's just how a programming language like C or Arduino C works. Other programming languages function in different ways. So now that we know we can basically slow down how fast time is passing just by dividing millis by 500 here, I'm going to go ahead and put the modulo back in place and say modulo 2. I'm going to delete these lines right here, and we're going to see these values of 0 and 1. This command allows us to alternate between values of 0 and 1. It gives us two states depending on the time. We either have a 0 or a 1, and each one of these states lasts a half second. Now that we know how to create kind of a state using the time, we're going to take that back to our ATtiny. So I'm going to go back, I'm going to copy this, I'm going to go back to the ATtiny program. And at the very top of it, I'm going to create a line that says byte and then state. And I'm going to set it equal to millis divided by 500 modulo 2. Then I'm going to create what's called a state machine using a switch case. The way it's very similar to if statements. I just type switch, and then I have to put in the variable that I'm going to look at. So I'm going to put the state in here. Remember, the state can only be two values. It can be either a 0 or a 1. That's what this command here is doing. I'm going to put the beginning of the switch right here, and I'm going to put the end of the switch way down at the very bottom. In a switch statement, you have different cases. The very first case is going to be case 0, and this is going to define what we do when the state is a 0. Well, the first thing I want to do is I want to go ahead and make the first pixel red and the second pixel green. And then I can delete this delay command now. And I'm actually going to just delete this strip. 'Strip show command now, and you'll see why in a minute here. And then I'm going to put a break statement. And so it's going to do this and then it's going to break, which means it's going to basically jump to the end of the switch. Next, I'm going to put case 1. And in case 1, I'm going to go ahead and put these two commands again. I'm going to delete my delay again. And this time, instead of deleting this strip show command, I'm going to cut it. And I'm going to put it right at the end, outside, right below the switch statement, the end of this switch statement. So this is where the switch ends. That's where it begins, right here. The command to show always happens, regardless of which case happens. And then I have to remember, I don't really need a break here, but I'm going to put it here just because down the road we're going to modify the code and we will want to have a break. So it's good form, it's good programming practice. I'm going to go ahead and close our serial monitor because we don't need it any longer since we're programming an ATtiny which doesn't have the ability to print to the serial monitor. And I'm going to go ahead and delete our Arduino Uno because it actually runs that program when we click the Start Simulation. So this will make our program work a little bit faster, our simulation work a little bit faster. Now I'm going to hit Start Simulation. And you can see our program functions just as it did before. Both LEDs are turning on, and as time passes, when we get to half of a second or 500 milliseconds, we should see these LEDs alternate colors. There you go. So we've achieved the functionality we set out for, which is to make the LEDs alternate just like we had, but this time there is no delay command being used. Your challenge is to add a third case so that you can control the third LED that you should have attached to your circuit and make these LEDs alternate between red and green and blue.